Hi, this is the second video in the playlist where we're looking at some additional revision work for the summer. Okay, it's aimed at around about grade 4, grade 5. It is higher tier calculator, however it's probably accessible to people who are doing foundation paper as well. So please do stop the video, have a go at each of the questions, compare your solutions. If you need any help, always add a comment, I'll always come back to you, and I look forward to seeing you inside the video. Hi, in this video we're going to be looking at another quick test, which is a calculator paper. Now it is aimed towards higher grade students who are taking the higher GCSE paper. However, it should be accessible to students who are on the foundation paper as well. So please do stop the video, have a go at each of the questions and compare your solutions. So the first one is: a lorry travels a distance of that in 3 hours and 25 minutes. Calculate the average speed of the lorry in miles per hour. So okay, all you need to do really is look at the formula: speed equals distance divided by time. Okay, now some people will use calculator, little triangles to remember this particular formula. However, the way I remember it is the speed is in miles per hour. Well, miles is a measurement of distance, per just means over, and hour is a measurement of time. So speed, miles per hour, is distance divided by time. Okay, so all we do then is feed in the information. Now the only bit we've got to be a bit careful of, we've got 200 miles, but the time itself is 3 hours and 25 minutes. And we've got to convert that to a decimal. So what we do is we say, well, it's 3 whole hours and then 25 out of 60 minutes. Okay, now if you plug that into a calculator, you'll be able to put that directly in. It's a little bit tricky, but if you've got a calculator to hand, I'll show you my particular calculator here. It's actually going to be this key at the very top here, which you'd access through Shift and then press the fraction key, and that will allow you to input a mixed number. Okay, so when you've done that, you should get something like speed equals 58, and it's some very long number like 53658. Okay, well, to one decimal place, that's going to be 58.5 miles per hour, and that is the answer to this particular question. Okay, let's move on then to question number 2. It costs £3.40 to buy 5 oranges. How much will it cost to buy 18 oranges? Well, basically, we need to work out the cost per orange. So what we would do is it's going to be 340 pence divided by 5. Okay, because it's £3.40 for 5 of them. Now, if you work that out, that's going to give you 68p per orange. Okay. All right, and all we've got to do then is just multiply that by 18. So we get 18 times 68. Now, bearing in mind, that's going to give you a pence. So it's going to be 1224p, which is going to be £12.24. And that's the answer to that particular question. Okay, hopefully that's all right for you. Okay, let's have a look at number 3. So it's calculate this. Now, you could plug that directly into a calculator and there'd be no problems at all with that. It would give you the calculation, providing you use the brackets and the division sign. However, I just want to very quickly say that actually, if you were calculating this, you would do it as 1.38 divided by 2.3, and then the standard form part of it is 10 squared divided by 10 to the power of minus 4. Okay, so you could work those things out separately if you wanted to, and what you're going to get is 0.6 times, now 10 to the power of 2 divided by 10 to the power of minus 4. We're going to subtract the indices, but you've got to remember this is a minus, so minus and minus becomes a plus, so it becomes 10 to the power of 6. 6. Okay, 2 minus 4. Okay, so therefore that would be the answer to the question, except it's not in standard form. So what we do is we move the decimal point back one place to make this first number between 1 and 9. And then because we've moved it back one place, we just reduce that by 1. 6 times 10 to the power of 5. Okay, hopefully that's okay for you. Let's move on then to question number 4. Now, the key issue with this one is it uses these words mathematically similar. Okay, so what we're saying is that there is a scale factor between this triangle and this triangle. This triangle is an amount bigger than this triangle. Okay, and the way we work that out is we use a calculator, and we can work that out that it's actually 3.5 times bigger. The way you could do that is you could divide 17.5 by 5 and you will get 3.5. If I multiply 5 by 3.5, I'm going to get 17.5. So I know it's 3.5 times bigger. So if I want to find the value of x, all I'm going to do is I'm going to take that 13, I'm going to multiply it by 3.5. So 13 times 3.5 is going to give me 45.5. So therefore x equals 45.5 centimetres. Okay, and that's the answer to that particular question. Okay, if you're not sure about any of these, I do have quite a few playlists on the channel, and if you had a comment below, I'll put links through to some playlists with some additional questions. Okay, let's move on then to question number 5. This particular one you might recognise as being actually Pythagoras, because this is a right-angled triangle. I just realised it's not printed particularly well. It's a right-angled triangle, so therefore we can use Pythagoras if we want to work out the value of b to c, which is this length along here. And the way I would do it is I would say, well, I'm going to use a squared equals b squared plus c squared. Okay, I'm very aware some people say c squared equals a squared plus b squared. Doesn't really matter. What we're basically saying is the hypotenuse squared, which is 9.4 squared, is equal to the sum of the other two sides squared. So 3.8 squared plus this, which we don't know, but we know it's going to be BC squared. Okay, so therefore it's really just a case of changing things around and making BC squared the subject of this particular equation. So what I would do is I would say 9.4 squared minus 3.8 squared equals BC squared. If you put that into a calculator, what you're going to get is 73.92 equals BC squared. Okay, square root of that then is going to be 8.597674, and that equals BC. Okay, and you'll go back to the question to one decimal place. Therefore, BC equals 8.6 centimetres. And that's the answer to that particular question. Now, just as an aside here, do make sure always that your answer is going to be less than the hypotenuse. Okay, this is why we subtracted over here, less than the hypotenuse. The hypotenuse is the longest side on any right-angled triangle. Okay, let's move on then to question number 6. Question number 6, we've got given that we've got this ratio A to B and B to C, okay, and we've got to find the ratio A to BC. These are not too bad, and I did a video on these fairly recently, so please do add a comment below if you're not sure, and I'll put the link through for that particular video. Okay, so we've got A to B is going to be 5 to 4, and we've got B to C, and that's going to be 9 to 7. So the problem we've got here is that these two numbers for the values of B are different. So what we've got to do is make them the same. So what I'm going to do is make them both 36, because I can say 4 times 9 is 36, and 9 times 4 is 36. So we've got them both the same. The only issue then is we have to multiply the other sides, in this particular case by 9. So that's going to be 45. And we're going to multiply that side by 4, which is 28. Okay, now because we've got b's the same, we can then write that in the form a to b to c is going to be 45 to 36 to 28. And that's the answer to that particular question. Okay, all right, so we are going at a fair old pace through this. I don't want to spend too long. It is actually the summer revision list, so I'm sure that you guys have got better things to do than to do a little bit of maths. Okay, but this is really good for revision, and it will keep your mind kind of ticking over before you get back to school in September. Okay, so this one is solve the simultaneous equation. So there's a couple of different methods to do this. The way I'm going to do it is I'm going to use the method of elimination. Okay, and the way I do that is I say, well, I've got 3x plus y and 2x minus 4y. So I'm going to make those values of x the same, because then I can subtract one from the other. So if I multiply this top equation by 2 and the bottom equation by 3, what will happen is I'm going to get 6x here, because 2 times 3x is 6x, and I'm going to get 6x here because 3 times 2x is also 6x. Okay, but I have to multiply all the way through the equation. So the top then will become 6x plus 2y equals 22, because each of these terms has to be multiplied by 2. Likewise, with the second equation, each of these terms has to be multiplied by 3. So I'm going to get 6x minus 12y, and that equals 3 times minus 9 is minus 27. Now this one is a little bit trickier because I've got these minuses knocking around, but we'll give it a go and see if we're okay with it, because we've got to subtract these two equations in order to get rid of the 6x's. 6x minus 6x is 0. Okay, then I've got 2y minus 12y. Well, a minus and a minus together becomes a plus. So actually it becomes 2y plus 12y is going to give me 14y. And that's exactly the same. The other side, 22 minus 27 is the same as saying 22 plus 27, which is 49. And then if I divide through by 14, I'm going to get y equals 3.5. Okay, now just as a bit of a tip on these, if you do get a very strange number, 3.872165, it's probably going to be incorrect. It's always worthwhile checking these, because generally speaking, it's either a really simple, straightforward decimal place number or fraction, or it's a whole number generally with these sorts of questions. Okay, so we've got the value of y. What we're going to do is then take that value of y and substitute it into the first equation. So I'm going to find x, and this is, as I say, the substitution method. Okay, and I'm going to use 3x plus y equals 11 for no other reason other than it's got a nice positive numbers there rather than negative 9. Okay, so let's have a look. Well, I've got 3x. I can't do anything about that. But now I know that y is 3.5 and that equals 11. So therefore, if I minus 3.5 from both sides, I get 3x equals 7.5. Divide through by 3 and I get x equals 2.5. Okay, so in this particular question, x equals 2.5 and y equals 3.5. Okay, there's quite a lot of simultaneous equations on the channel, so if you're not sure, let me know and I'll put the link through. But either way, please do stop the video, have a go at each of these questions and then compare your solutions. Okay, so this particular one then is Kavin bought a boat for 65,000. Okay, in the first year, the value of the boat decreased by 25%. And the second year, the value of the boat increased by 10%. Calculate the value of the boat after 2 years. Okay, so it should be fairly accessible with a calculator. So basically, in the first year, or at the end of the first year, he paid 65,000 for the boat. Now it's worth 25% less. So if I multiply it by 75%, or the decimal equivalent is 0.75, then what I'm going to get is going to be 48,750. Now, in the second year, what that means then was starting with the 48,750. And in this particular case now, it's actually increased in value by 10%. Very unusual for a boat to increase in value, but they do occasionally. So what we're going to do then is multiply it by 110%, or if you prefer, the decimal equivalent, which is 1.1. Okay, I put a 0 on the end. That's 110% as a decimal, and that's going to give us 53,625. So at the end of the 2 years, the boat is valued at 53,625, and I'm sure Kavin is very happy with that. Okay, all right, I wish I had a boat at 65 grand. Okay, number 9 then. Line A passes through the point 0.5 and there's a gradient of a half. Write down the equation of line A. This is really straightforward. It's just the wording that makes it difficult, because you can imagine what we've got is a line. It passes through the point 0.5. So 0 is the value of x and 5 is the value of y. And it's got a gradient of a half. So in the form y equals mx plus c, we can just simply put these numbers in. So the equation of the line will be y equals m, which is a half, x, and rather than plus c, we know it goes through plus 5. And actually, that's the answer to that question. So relatively straightforward. And again, if you want some practice on these questions, let me know in the comments and I'll always come back to you. Final question. You'll be pleased to know that's 15 minutes or so into the video. Let's look at the final question. It says the bearing of Crow's Nest from Deacon's Hill is 140 degrees. Okay, so the key word with this is from Deacon's Hill. So if we're on Deacon's Hill, this is north. Okay, and Crow's Nest is going to be roughly on that bearing, which is actually 140 degrees, and we're going to get to Crow's Nest. Okay, and the question is, what is the bearing of Deacon's Hill now from Crow's Nest? So if we look at the bearing, if we're sitting at Crow's Nest, we need to calculate this angle, because you'll remember that bearings are always clockwise from north. Okay, so this is north and we've got to go clockwise. Now, probably the easiest way of doing this is to look at the diagram that I've drawn and see that actually this is a corresponding angle. So this bit of it is 140 degrees. It's the same as that one. It's this very classic kind of F shape that you'll see when you're doing angles in parallel lines. Okay, and then we've also got this line along here, which is the rest of the bearing. So we've got 140 degrees to there, and then the rest of the bearing is going to be an additional 180 degrees. So the actual bearing of Crow's Nest to Deacon's Hill, I don't know if anywhere exists called Deacon's Hill, but I thought it sounded good. Okay, and that's going to be 140 plus 180 degrees, which is the straight line, and that's going to give us 320 degrees. So the actual bearing is 320 degrees. Be very careful about those questions. Really popular. They do come up such a lot. Okay, I hope it's been useful to you, the video. Please do leave a question if you're not sure about anything. I'll always come back to you, and I look forward to seeing you inside the next video.